All right, so this is an interesting part of this applications of logs and exponents. We're going to be determining different rates of change. So, for example, if I tell you this is the formula for compounding something quarterly, you know that that 4 is there because of the quarterly part. So what is the percent rate of change? The quarterly percent rate of change. Well, it's worked out the same way as always. We do 1.023 and we subtract our 1 and we get 2.3%. Now, so if I said, well, how much, if I compounded quarterly, how much would I be making, or how much percent would happen over the course of a year? So this is going to change. If I keep adding the interest on over the course of the year, I'm going to be adding it on 4 times instead of the annual 1 time. So to figure this out, all you really have to do is take that 4 and bring it inside. Because whenever we have an annual percent rate of change, excuse me, there we go, we have just a t out here, and that's the annual percent rate of change. But we don't want to change the rate. We don't want to make it a new formula. We don't want to do that. All we want to do is, we're going to keep this trend. We're still compounding it quarterly, but how much can I expect over the course of a year? And when you do that, you know, this stays the same, and this really has no part of this kind of question. You get 0. Here we go. I got this. Okay, so we have this is the number that's in there if I just raise this to the 4th power. So we kind of did this before, and we do the same basic idea. We do this minus 1, and we wound up just taking off the 1. So the percent rate of change is this. I move it over 2 decimal places. So the nearest tenth of a percent would be 9.5%. And that kind of makes sense. If you have 2.3% you're getting every quarter, then over the course of a year, 9.5% kind of makes sense. All right, so this question is asking it slightly different, but it's the same basic question. We're saying this is a monthly rate of change, but they only put M here. So really what should be there is M really is 12t. Remember, monthly, if you compound monthly, it's 12 times a year. So when we do this, M is actually should be 12t. Just to keep that in mind. So if I'm asking for the monthly percent rate of change, this is it's a decay or a decline or a decrease or whatever, however you want to call it. So 1.1 minus 0.98. 0.02, move it over 2, so it's a 2% rate of change. So it's declining 2% every month. Okay, whatever it is, it's going down 2% every month. So if I do this, well, what would it be every year? So over the course of a year, how much is it going to be decreasing? So what we have to do is we have to take this 12 here and bring it in. So it's 0.98, and remember the 3200 really is not part of the percent rate of change. That's just if we actually needed the formula. So what I do, I mean, I can put it if it makes you feel better. So I'm such a jerk. So what happens is when we do 0.98 to the 12th power, I get this, etc. To the t. So now this is what would be changed annually. Because this is this right here is a t, even though it looks like a mess. This right here is a t. So this is going to tell us the annual percent rate of change. And since it's decay, we do this, and we wind up getting 0.21528-ish. Move it over 2 decimal places, and it's 21.5%. Again, kind of makes sense. If it's changing 2% every month, then over the course of a year, 21.5 makes sense. So now going the other way, if I give you an annual kind of problem, so the following formula has a trend in aardvark population. Yep. It's got 2 A's. All right, so anyway, so this is, as you can see, this is the aardvark population is increasing thanks to conservation whatever, I'm just kidding. I made this up. So what is it increasing by? So if it's increasing every year, what percent is the percent rate of change? Well, you remember we just subtract 1 and we get 0.12. Move it over, so it's about a 12% rate of change over the course of a year. So I'm going to ask you, how much is it going to change over the course of a month? Like every month, what's it going down? Now, I'm going to guess, this is 12, I'm going to guess it's about 1% every month is going down if we keep up this trend. That kind of makes sense to me. So what I need to do, I need to look at the formula. I need to make it so that this formula has a 12 here. This 12 here is going to be the percent rate of change. It's going to help me find the percent rate of change for every month. So every month, that's going to be a 12 there. Well, I can't just put a 12 there. That's just not allowed. I can't just put a 12. I got to do something. Well, what I do is I put a 12 over 12. Okay, and basically what that means is I'm going to put a 12 here. Hold on, I got this. I don't know. Weird things are happening. I put a 12 here, and this is 1 over 12. So if you think about it, I'm doing 12 over 12t, and I'm taking this, the bottom one, and I'm bringing it in so that I can have the top one. We're just playing with numbers a little bit here so that I can wind up having a 12 on the outside. But since I can't do that directly, I have to do that 1 over 12. So what happened was I kind of broke this up. I left the 12 with the t, and I brought the 1 over 12 and I put it inside the parentheses here. So I wind up getting this. So if you want to think about it, you know, on the other side of the paper, we were raising it to the power because I was trying to get the annual percent rate of change. Now I'm trying to get a smaller percent rate of change, so I'm doing more of a dividing, if you want to think. So when I do this, I get, excuse me, I need my paper, 3652, and it's 1.00980, whatever, it's up there to the 12t. So interestingly enough, if I do the subtraction, I do this minus 1. I wind up 0.00948. Move the decimal place over 2. To the nearest hundredth of a percent is 0.95%. Close enough to 1% to make it seem like that totally makes sense. So it's going down almost 1% every month, so at the course of a whole year, it goes down 12%. So that is kind of figuring out different percent rates of change. And for all my fans out there, have a good day.